Okay, thanks everyone. Hope you're not falling asleep after lunch. So first of all, thanks Erica and Permissionless for organizing this. Really great to be here in New York. And for those who are not familiar with me, I'm previously a researcher. I worked actually with Yunsol back at Google for a bit. And I'm one of the co-authors on the paper "Attention is All You Need" that introduced transformers, which is technology powering most of the LLM nowadays. Now, I left Google because I wanted to apply this technology to what now we call vibe coding, right? We were teaching machines to code, and it was too early. The GPUs didn't work. But one of the things we were doing was actually doing a lot of crowdsourcing, data labeling. And we had students, computer science students in China, Eastern Europe, Southeast Asia, who we had challenge paying, right? Students in China don't have bank accounts. They have WeChat Pay. In Ukraine, you need to sell half of your dollars. PayPal didn't work in Russia, et cetera, et cetera. And so we focused on building near protocol because we needed to solve our own problem, which is how do we pay and coordinate people at scale in easy programmatic way. So Near started as that, but obviously the world is evolving, and let's talk about where we're going. I actually believe that AI is effectively the last technology wave. At this point, we already see that AI is becoming the way we do all of the other technology research and innovation. Last year, 2 of the Nobel Prizes were effectively given to AI. I mean, they were given to people who built it, but it should have been to AI. And the thing is, like, whoever controls this AI controls how you can use it. They define what you can ask and what you cannot. And so they effectively control everything that will be developed and done going forward. So it's really important that we actually understand how this control is done. And so there's a lot of actually foundational challenges that right now are with AI kind of in traditional way, right? I mean, you also mentioned a lot of the kind of problems with just closed source models. Like, you don't know what's actually happening there. There's a lot of complexity there, but also the company can change the rules on how you can use it. Like, today you can ask medical question and tomorrow you cannot. Today you can ask about analysis on financial data and tomorrow you cannot. Even more, if you're a nation state, right, one of those companies can just turn off access to the whole country at one person's whim. So you have potentially massive GDP implications that can happen from this. You have a ton of energy kind of intensive compute that's needed, and these companies actually have a trust problem. They are not able and not wanting to give their weight to other compute providers in other locations because they don't trust them with their weights. Weights are the IP that's extremely valuable. And so what happens is they're building bigger and bigger data centers in one location, which requires more and more energy, right? There's like 100 or 200,000 kind of H200s data center in Memphis that effectively sucking in all the energy from the city. Versus, you have, different data centers around the world that could be serving this. You have a number of safety issues in general, right? Like, you don't want to give model that can help people produce, nuclear weapons and biological weapons, but the rules that like actually define what is it and what not are not clear. Again, they're changing underneath all the time. And then on the other side, obviously, we have open source models which are, accessible to everyone to use. And so you have all of these things. And for open source, we have a challenge with monetization, right? It takes a lot of money. It takes a lot of effort to actually build these models. But there's no way, if you put out the weights, to actually monetize and feed back into researching and developing a new model. Now, on the other side, we have a paradigm shift, right? Kind of past, I would say, 20 years have been all about our ability to use browsers and applications to navigate the internet, right? We effectively, the Web 2 internet was built on advertisement, payment processors, and search engines, and in general, these aggregators like Amazon, DoorDash, etc., and applications that are built by someone and kind of shipped as a piece of code to your device. Now, with AI can actually produce all of this code, or soon will be able to produce all of this code on the fly. You can actually customize and modify the experience you have with your AI. even more, your AI doesn't actually need, an aggregator and, three middlemen that right now are happening for any kind of commercial activity, buying things or interacting with services. Your AI can go directly to a pharma company and talk to their AI and figure out exact medicine, exact compound that you need and ship it to you, right? There's no need for FDA, pharmaceutical companies kind of selling it to kind of this pharma intermediaries who then sell it to pharmaceutical pharmacies who then sell it to doctors, right? All of that can be cut out. And so we have effectively this new transition where you have AI first experience on your devices. It's controlled by your AI assistant. And then you have AI agents operating by services and companies, which effectively your AI can talk directly. And we need this agentic infrastructure for them to peer-to-peer talk to each other. Right, so this is a transformation. We're going from effectively internet with, you going to a web server and the web server gives you a web page that they provide that you use, to your AI now just directly talking to AIs of different services to get things done. And so there's a lot of challenges that can come from this if we don't handle it properly, right? Again, if your AI assistant knows everything about you, knows your medical history, your financial information, your, every conversation you have during the day, and all of this is sitting on somebody else's server that gets hacked, or, they implement the access control and somebody else accesses all of your information, that's a really bad situation. So all of those challenges that I outlined, this is where blockchain kind of Web3 approaches really comes in and can solve a lot of this for AI. And so here is effectively this blockchain for AI, the infrastructure that's powering this user ownership and kind of transforming away from the current kind of few centralized bodies providing us the services to really a decentralized network of participants and decentralized protocol of how they communicate with each other. So what is blockchain for AI? Well, it's really about your user-owned, AI assistants and agents communicating with other AI agents and assistants, as well as with autonomous businesses, right? We're not just going to have, other companies which are, run by people. We'll actually have autonomous businesses which may still have shareholders who can decide on direction, but the business itself is run by AI. Now, right now it starts with crypto, right? Right now we have these examples in crypto space, and I'll talk through some of them, but this will expand to everything we do online, right? As the infrastructure on how to on-ramp, off-ramp, how, for example, autonomous agent can own a business, a physical business, how it can hire people matures, we'll be able to actually do all of these things online as well. So what are the different there's effectively three major aspects, right? So first of all, there's foundational models and infrastructure. This is all, what we usually consider inside the foundational companies, those frontier companies. This is all about how do we actually train AI models at scale in such a way that they're user-owned, that they're community-owned, that they're not kind of owned by a singular company. It's also about this infrastructure of how any like my agent can talk to your agent in such a way where there's no middlemen, there's no intermediaries, and we can actually have a commercial agreements between each other without involving a bunch of lawyers. So this is kind of the unified markets structure. Now, then you have agentic protocols, right? The autonomous businesses that can kind of transact, that can own. It starts with DeFi, but it expands to traditional businesses. And then you have assistants, right? This is what runs on your device and really is on your side, helping you day to day, week to week, year to year. So there's a lot of components that go into it, right? The blockchain is obviously one of them, but you also need secure enclave infrastructure so you can actually run these models in verifiable and importantly confidential way. You need a governance system that is able to handle conflicts, and if AI cannot resolve them itself, right? So if we made some commitment that something will arrive, if that didn't happen, and AI went investigated, and if there is no resolution, you still need to go to some governance system. You need a system kind of to unify markets. This is what we call intents. It's ability to specify the outcome you want and have somebody else come in and fill it in, effectively provide you a path on how to achieve this outcome. So this is all the infrastructure that is effectively been built in the Near ecosystem. So on the blockchain side, for those who are not familiar, Near has been around for over 4.5 years, zero downtime, has had over 50 upgrades, and at this point sits with 8 shards. We also recently reduced block time by 2x down to 1.2, 600 millisecond block time, 1.2 second finality. This is about 10 times faster than Solana, 600 times faster than Ethereum in the layer 2s. And we also working toward adding sharded smart contracts, so you can actually have applications and contracts that scale with the blockchain itself and actually can handle tens of and hundreds of millions of users. We have 3 or 4 applications like this right now that need this. Now, on the foundational infrastructure, right, we are building kind of the whole stack of different components that actually form. If you look inside any AI lab, they have kind of all of those pieces, right? A lot of it is about, kind of GPU infrastructure, human labeling data, synthetic data, how to do, retrieval augmented generation, private user memory. How do we actually enable confidential inference? How do we do model training in such a way that we know what data went in, but we actually can monetize the model? So one of the things we're doing with secure enclaves is you can effectively know exactly what training data went in, what code went in, but because it's trained inside confidential environment, the outcome model is encrypted. And so now you can still use it, but you need to pay for usage, right? It's not fully like open weights model. It's encrypted weights model, but it is open source. So this is kind of innovations that have been built across the stack. You have benchmarking and evaluation. One of the important components of AI has always been, kind of how do we measure the progress? How do we innovate here? And so how do we create an incentive in blockchain space to create new benchmarks and new and kind of incentivize people to try to beat them so we can continue innovating on the models. You have agent hosting and analytics, right? There's a lot of agent builders, but there's not a lot of agents actually working consistently because there's a lot of problems when you actually put them in production with how they work. So you need a lot of analytics and debugging to ensure that you have high quality agents. All of this is actually built by different teams in the ecosystem. A lot of them are still stealth. This is the stealth icon. And so all of this together, they're working, using each other's infrastructure and effectively enabling these new experiences. All right. Now, all of this kind of composes this infrastructure we call decentralized confidential machine learning. So this is combining the secure enclaves and confidential VMs that were built by Fala with a protocol called proof of response to enable effectively guarantees around liveness of the nodes and making sure they actually respond. And together, this provides us something similar to, Amazon Web Services, where you can actually, use a service, but the guarantee is there's no single person or entity that is able to access this data or stop you from using this, right? There's no effectively KYC. There's no ability to prevent people from using this. Obviously, you have smart contract on chain to register the nodes, to pay for usage. You as a model provider as well, it solves your problem if you built a new model, right? Let's say a new innovative use case. You can actually host the model here in encrypted format, and it gets decrypted only inside the confidential VM, and meaning that now you don't need to build your own inference cloud to effectively monetize it. You can just serve your model, and it gets you get paid when it's used. So it's similar how we usually think of smart contracts, right? As a developer, just deploy smart contract, and people who use it pay, and you just make money off it based on the financial model you build. This effectively provides us with a system for doing that with models and agents as well. Now, on the unified market side, this is how we actually unite all of this with the commercial agreements, right? AI right now exists in this like information land. It's really just retrieves information, answers your questions, and suggests you things. It doesn't actually do things in real world. Well, with this new type of transaction we call intents, we enable a way to effectively for AI or people to create commercial agreements between each other and settle them on chain and effectively create this binding commercial agreement that then can be adjudicated and arbitrated by AI and by governance. So it started with just simple crypto trading because it's really easy to adjudicate it. Hey, did you receive the funds that you were asking for? And so intents have been growing really nicely. But now the next step is AI marketplace, right? Where you can just describe in natural language what you want to achieve, right? I want to build this website. I need to do this analysis. I actually want to plant a tree outside of this building.